Okay, this morning is Tuesday, December 7th, correct? 6th. We have just two questions for our warm-up this morning from 5-2. It says, what are like terms? And like terms, by definition, are, well, oddly enough, terms that are identical in every way except they don't need to share what? Coefficients is correct. So, for example, if I said x squared y, and I said I have three of those, three x squared y's. And then I said, and I was thinking about negative 2 x squared y. These two terms are identical in every way except for their coefficients. So therefore, we would say that 3x squared y and negative 2x squared y are called like terms. On an easier level, if I said 4x squared and 3x, are they like terms? No, because this term has an x squared and this term just has one x. And if we think about what that looks pictorially, an x squared is this, and then multiply it by 4, it'd have 4 of them, right? And 3x would look like this. So pictorially, we're representing something completely different. And symbolically, this is 4 times x, where this is only 3 times just 1x. So those would be considered not like terms because they are not identical in every aspect. And in our last question, question 2, it says gather like terms. There are two ways to do it. You could pictorially draw them, so 4x negative 3x squared, so negative is going to be unshaded squares. 2x 5, I'm just going to use integer chips for this, positive 5, negative 7, and finally 4x squared, 1x squared. Because they're positives, I'm going to shade them in. So pictorially, that entire 6-term polynomial can be represented with that picture. And then what we need to do is look for similar shapes. In AKA, instead of saying similar shapes, we would say look for like terms. These 4 and these 2 are going to make 6x's. And 6x's plus negative 6x's, what's that going to make? It's going to make 0, right? These 4 here, or these 6 here, with those 6 negative x's, are going to combine to make an algebraic 0 pair, leaving me with just a negative x. These 3 negative x squareds and these 3 negative x squareds are going to combine to make an algebraic 0 pair, leave me with just a plus x squared. And the constant of 5 can't combine with anything else. So all we're going to have there is a plus 5 constant. Now there's something that I didn't tell you that I should have said to you. When you actually gather your like terms, when you box it up, the other way you could have done it is just simply box it up without drawing it. Include the operational sign with your term, and then ask yourself, of those 6 terms, which term has the highest degree? Your x squared terms. So the first thing I'm going to do is combine this term with this term. And when I do so, I'm going to write my x squared because that's the actual type of term. And all I'm really going to do is combine those coefficients together. So what's a negative 3 and a positive 4x, or negative 3 and a positive 4 make as an integer? 1. Now, do I need to write a 1 coefficient? No. So I could just leave it as x squared, or if you wanted to, you could write a positive 1 coefficient, but it's poor form, so you just keep it without the coefficient. A 4, these 3 here, these 2 coefficients are going to make a positive 6. Combined with that coefficient is going to make a negative 1. And again, do I need to write a 1 coefficient? No. So instead of writing negative 1x, I can just write negative x. That's negative 1. And then finally, your constant of 5 It's there. So what I want you to consider is, if I take my yellow highlighter, this answer and this answer are the exact same thing, aren't they? The only difference between those is the order in which I express the terms. In this one, I did not express it in descending degree of terms. I just simply looked at what my first term was and gathered that first, and then looked at my second term and gathered those. Whereas this one, I actually put a little bit of thought into how I was going to gather them, and I gathered my highest degree terms first. This is what I want you to do when you write questions, is write them in descending degree of terms.